Hello, here's Ms. Walsh, and we are going to do day 4 today. Nearest neighbor interpolation. Okay, for example, let's consider a map down below showing the measurements from the rain collection at the stations. Okay, so this of course is not a Voronoi diagram, but you can see here it is, right? Because you've got those perpendicular bisectors going all throughout. Okay, well, if you have a measurement, something like, let's say it's 6, and 4, if you're closest to the point P, then you're going to take the measurement that is given at P. That is basically what the nearest interpolation mean. Doing it a little bit more in context, if you have, for example, again, this is like a weather company that records at 3 different locations. If you have, so you've got 22 degrees, and this one records 18, this one records 17. If you are at -1 and 4 here, then you can see you're in the region. You're in the region that is closest to A. And so what you're going to do is anywhere here, you're going to be closest to, let's try the pen again, there it is, to A, okay? That's what nearest neighbor interpolation means, okay? So all of these would be, anywhere in this region would be the nearest neighbor would be A, okay? So what would it show? If you're here, then we would take the temperature to be 22 degrees, okay? If you're at 3, -2, very similar. Now you can see that you're closest to B, so using your nearest neighbor is station B, and so hence you're going to be taking 18 degrees. Super easy. If you're at 1 and -1, you're at 1 and -1. Okay, so now you can see that you're at the intersection. So if you're at the intersection, then what you're going to do, you can probably guess, is you're just going to average them out. Since this is an intersection of all 3 edges, we're just going to average all 3. So you're going to have 22 plus 18. That's the concept of the nearest neighbor. Add those up, divide them by 3, and then you're taking the average reading. Okay, let's try this with another question. You'll see that sometimes you're asked something a little bit different. We're going to be asked the area here, but all the same thing. Okay, what's this? So we've got rain gauges in a wildlife sanctuary, and each unit represents 1 kilometer, both horizontally and vertical. It is worth it to just always check your scale. Okay, find C missing from the diagram. Where's C? C is clearly somewhere here, so you could try and do this, but you know that this edge divides A and this, and since this is a vertical edge, then 1, 2, 3, 4. I can just go 1, 2, 3, 4, and you know that this is where C is going to be. What's the coordinates of C? C is going to be at 11 and 8. Good. Okay, calculate the area. Okay, so again, something a little bit new. I don't think we had to calculate area up to then, but this is just a this is just a triangle where we can have the base and the height. Sorry, it's not a right triangle, but okay, so then here, how much is this? Is going from 1 to 13, so our base is 12, and this is going from 8 to 2, so this is 6. So you can just, this is 6 and 6, and so you're going to have 36 square kilometers. Okay, find the distance already. Find the distance from point E, which is at 14 and 4. E. Oops. And the nearest gauge. Okay, where are you? You can still see that you're still here, right? So C is going to be your nearest neighbor. So all you need to do is you just need to find this distance. Remember, we determined that this is 1108. You can just go for your formula booklet, and you do have the distance formula there. It's just the difference between the x's and the y's, of course, which is just a Pythagorean theorem thing. Okay, so then we're going to have 14 minus 11 squared, and then we're going to have 4 minus 8 squared. Oops. And then this is going to be, what is this? This is 9, and minus 4 squared, this is going to be 16, so this is going to be root 25, which is, of course, 5, okay? So that distance is 5. Okay, the average monthly rainfall of each site is given in the table. Find the average monthly rainfall at F being at 2, 4. Okay, where's 2 and 4? Okay, there's F. You can see who is the nearest neighbor. The nearest neighbor is A, so that's the gauge you're going to take. So since it's closest to A, then we're going to be taking the gauge of 210 millimeters, okay? That's how that concept works. One more, okay, cellular phone tower. Okay, so now you have PQRS, not shown yet, partially complete. The regions are created, provided by the tower. Write down the coordinates of the missing cell tower C. Where is it? Well, obviously this edge is splitting up the Q and something else. This is a horizontal line, so all you have to do is just go swoop, 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 swoop. So this is where S must be, right? Horizontal line, so they have to be on top of each other. So therefore, this is going to be at 7 and 1. Calculate the area provided by the phone tower Q. So all of this. Again, area, feel free to pause it. Feel free to always, try these questions on your own. Half times base times height. What is this? This is from 4 to 10, so this is 6. And then this is from 3 to 8, which is 5. So you're going to have 6 times 5 divided by 2. It's going to be 15 square kilometers. Find the gradient of the edge of the Voronoi diagram between Q and R. So all they want this gradient. Okay, that's not a big drama. Notice always check the scale. So here we are using one step for 1 unit. So 1, 2, 3, 4, 5. So when 1 up, 5 up, 2, 3, 4, 5, and 5 to the left. Okay, so then the slope is going to be 5 up, 5 to the left, which is -1. A customer is located at 410. Okay, here we go. And then determine the download speed that she receives. Okay, again, by your nearest neighbor, you can see that she's closest to P. And so then at P, you can see that you have 25 megabytes per, I guess this is per second. Okay, so that's going to be your answer. Okay, and that's it. Short and sweet, nearest neighbor. Done.